Hi, this is Miss Litton, and once again, this is my wonderful 7th period APBio review, and we are going to focus on the what? Science practices, and they are enthused, let me tell you. Okay, so the first thing we discussed in science practices are the ones you're going to need to be comfortable with for your APBio exam. Tomorrow we're going to be doing the very first one about modeling, right? And we have a lab coming up, and hopefully you have everything set up and ready to go. Where did I tell you how far you needed to be? Data table. Good. Okay. We are going to practice doing some math right now. Scientific questioning. You have a driving question. We want to have good data collection. We want to perform analysis and evaluation. Our chi-square test will help us with that as well. Work with scientific explanations and theories, and then we're looking across disciplines as well and using physics and chemistry. Now, I know you have a good idea over the process of the scientific method, but we went to this slide right here. And once again, do these two things, and you want to be able to have a better explanation for number 2 than you did the first time we discussed this. Go ahead. Oldest, youngest, do your business. Vaishnavi, how are you today? I just wanted to say thank you. How are you today? I just want to say you So, you can test many things, and some things you will reject. Why will you reject them? Yes. Wait, Krishna, did I do it? You should be more proud of me. Okay, so why can you reject them? Go ahead.
There's a significant chain in data that proves your hypothesis.
And how do you know that?
Chi-square.
Chi-square test, good. You're going to use some math to decide if it's significant or not. Good job. Because these are the things right here we're trying to find out. How do we know if it supports our hypothesis? And when are the numbers significant? We're doing a new lab, and I'm running some numbers over here, and I'm going to tell you right now, is for a fossil class, I do not think they're significant numbers, which is bad. But it worked sometimes and sometimes not. Yay, science! And then that'll help us to know whether to accept or reject our hypothesis. So we talked a little bit about a review about independent and dependent variables. Could the oldest bio buddy explain the difference between those two right now? And come up with an experiment where you would come up with a hypothesis and identify your independent and dependent variables. Go. Who just went oldest or youngest? Oldest. Okay, are you good with this? Pretty easy? Okay, youngest, could you please explain? I'm not going to do the wall of words again, okay? Just overview, research hypothesis. You're looking for connections between A and B. Null hypothesis. You're saying there's no connections, but you're doing that to kind of show that there, what? Is a connection, if there's a significant difference. Other bio buddy, could you please explain this that we're adding on? What's the difference H1, HO using this? Go. All right. So we jumped in and we asked the question, is there a connection between sleep and grades? And if you're writing an H1 hypothesis, and a research hypothesis, you're going to say that there what? Is a connection. What might that connection be? What would you assume the connection would be? If I get more sleep, I will what? Get better grades. Okay? But we said that's a hard experiment to control, right? Because there's so many other factors. So we decided instead of doing a research or alternative hypothesis, we're going to go with a null hypothesis. We're going to say that there is what? No connection. Because then if we compare the amount of sleep with people's grades that they're earning, we can do the chi-square test to see if possibly it looks like we can disprove the null, which then supports the idea that sleep is a factor in your grades. Now, turn towards your bio buddy right now and say, do you get the premise of the H1HO hypotheses? Go ahead. Okay, now come back to me. You may be thinking H1 all along, but you're going to say the opposite of it and disprove it to support the H1. Got it? All right. So disproving the null can support the alternative hypothesis. And we started off, and I'm not going to redo the ones we already did in class. We said, if I deal out 20 cards, I expect what? 10 and 10. If I can keep going if you can keep going. Okay. So I expect 10 and 10. If I get 19 and 1, do you think that's going to be significant? Okay. What would we do? Don't make it complicated. What would we do? I get 19 red cards and 1 black card. 19 red cards and 1 black card. What am I going to do? I'm going to take the what? The difference between what I expected and what I actually got. And I'm going to do that for both of them, right? Then all I'm going to do is take those numbers and I'm going to what them? And then I'm going to add them and then I'm going to what? Look on the chart, right? Okay? Okay. Oh, did I not say the divide part? Oh, dang it. Okay. Try it again. Shoot. Okay, I'm going to take the what? Difference. Okay? And then I'm going to what it? Square it. And then I'm going to divide by what I expected. And then I'm going to add them. And then I'm going to look on the chart. Okay? If I have 3 different kinds of data I could get, or 4 different kinds of data I can get, okay? 4 different results I could get. My degrees of freedom is always going to be what? 1 less than the total I have. So if I have a red card and a black card, and those are my only 2 choices, I have 2 choices, take away 1, my degrees of freedom on my chart is 1. If I have 4 choices, spades, clubs, diamonds, and hearts, I'm going to take away 1, and I will have 3 degrees of freedom. And I will look across the chart. And the big line that's super important, whether it's significant or not, is what percent? 5%. Yeah, 5%. I'll show you that again. We can take a look at it. Okay, so we look right here. Okay, this is our line. This is our line that says yay or nay, if it's significant. This says how often this could happen due to chance. It just would happen that way. You know, we look up, take our number that we calculated, we look on our degrees of freedom, we said, that could happen by chance. Maybe it happens 70% of the time. Maybe it happens 10% of the time, but it could actually happen by chance. This right here, it's saying, what are the odds that would happen by chance 1% of the time? This is probably significant at that point when you get those types of numbers. So what we want to look, here is the equation overall. And this just says, what does this E mean right here? Sum. And I just take the differences squared, each of the differences squared over what we expected. And we looked at this one right here. We looked at chemists being women. Only 35% of all chemists are women. Did we determine that was significant? Yes. Yes, because we would expect, if it wasn't, like if we would say, if we went with the null hypothesis, we would expect 50% of the chemists to be women and 50% to be what? Men. So we would take the difference between that, and this is how I started you off, okay? We would take the difference between them, square them, and put that over 50%. Add add those two numbers together, and that's what we did right here. Add those two numbers together, and we got 8.8. We were either male or female, so our degree of freedom was 1. And we pull out the chart. 1 degree of freedom, go over to 8. We're not even on the chart. So this is significant. There is some other factor that is affecting why there are fewer chemists that are women. Okay, we then ask your bio buddy, were you good with that one? Yeah. So, did I disprove my null hypothesis? Yes. My null hypothesis said there's nothing wrong with the number of women. That could statistically happen. That could be due to chance. But when I did the data, I am not getting when I ran it again. Like it's a difference of like 10. Are you getting this? Okay. Are you leaving right this second? Oh, go for it. Okay. So Miss Kawakatsu is a chemist.
Hello.
And Ms. Kawakatsu, what did we find out? How many women are chemists? 35%. Did we find out if that is significant? Yes, we did. We learned that. Okay. Questions? Yes. Which one, sweetheart? This one? Are you trying to capture that? There you go. You have the chi-square test, by the way, on your important formulas and equations that you have papers for this class on your anchor page. All right, let's go here. Here. You have cards. Okay? If we work this out, if I'm dealing out 20 cards, I'd expect clubs, hearts, spades, and diamonds. If I deal out 20 cards, I would expect how many of each? 20 cards, 4 different suits. Okay, wait, let's answer this question. 20 cards, 4 different suits. How many would you expect? 5 of each. Yes?
So how do you know if it's significant when you look on the chart, like what base it?
Anything, if it's a bigger number than 5%, that's your cutoff point. Okay, so I would expect, did I get 5 of each suit? No. So if here I got 1, 2, 3, 4, 5, 6, what was the difference? 1. So that would be 1 squared over what? 5. Right? Here I got 1, 2, 3. What's the difference? 2. So that would be 2 squared over what? 5. Here I got 1, 2, 3. What's the difference? So I'm again 2 squared over 5. And here I'm 1, 2, 3, 4, 5, 6, 7, 8. What am I? 3 squared over 5. Could you do that? Difference squared over what we expected and just add them up. That number equals your chi-squared number that you're going to look on the chart. We can do that, right? Okay, so I did the math for you here. And our number that we came up with when we squared and divided by 5 was 3.6. Well, we're not looking at the same place. We're not looking at the same place on the chart anymore because we have 4 suits. So how many degrees of freedom do we have? 3. So I go down to 3 degrees of freedom. And what's my number I'm looking for? Oh, I found it. I'm in the good times. Okay. So is there anything wrong with my card sorter? No. If I wrote a null hypothesis, I could have written there is nothing wrong with my card sorter. And I proved it, my null hypothesis. There wasn't anything wrong with my card sorter. Right? You could write a research hypothesis if you wanted to as well, but on that case it was easier just to do a null. Yes?
Will we be given that
yes.
chart?
Yeah, you could be given this chart just like this.
And it'll always show us where the cutoff is?
Yes. Well, you know, yeah, it's always right here. 5% or 0.05. That's always the cutoff. Always. Okay, ask your bio buddy, are you good with this cards one? Okay? There was one more. one more example I think I did here. Now, this one was a little bit harder, but I think it's manageable, and the answer was on your paper. So a university conducted a health survey of their recent graduates that included a question about the number of times students worked out. 60% said they did not work out, 25% were sporadic, and 15% were regular exercises. That is our initial information. Did they tell you how many students there were? No, we just got that data. Then the university launched a health promotion campaign and repeated the survey the following year. Of the 470 respondents, 225 said they didn't exercise, 125 were sporadic, and 90 were regular exercises. Could we convert those to percentages? All we would have to do is say 225, does anybody have a calculator? 225 divided by 470, what is that? 48%. So then it went from 60 to 48%. Is that right? I'm not looking.
54%.
It's 54? Okay then. Okay. 54. Okay. Then it is 125 said they were sporadic. Okay. What's 125 divided by 470? What is it?
26, but 26, 27 if you round.
Okay, 27%, but we would keep it unrounded if we wanted to. And then 90 were regular exercises. What's 90 divided by 470?
19.
19%? Okay, so if we want to know, did your campaign make a difference? Was it significant? Did it alter the behavior enough that it was significant? So if we wrote a null hypothesis, we would say, it's fine. Okay, there's no difference. No real significant difference. If there's no real significant difference, then what we would expect is 60% again. We didn't get 60% that said they didn't work out. We got 54%. What's the difference between 60 and 54? So 6% squared is what? 36 divided by what we expected, which would be 60%. That's our first number. See how I'm doing that? The next one, if it made no difference, it should have turned out the same. 25% would be sporadic, but it's 27. What's the difference? 2%. 2% squared, 4% divided by 25%, what we expected. Okay, the third one was 15%. What's the difference there? 4%, right? 4% squared is what? 16 divided by what we expected, which was 15%. Okay, or you can change them into people. The other way to go about it would be to take 60% of 470, okay, and 25% of 470. That would be the other way you could work this problem. And then you could just do number of people divided by it. Okay, and when you do that, okay, and you do your chi-square test, and you add up the number, it's 8.48. So how many choices did we have? No exercise, sporadic, and regular. So we had 3 choices. So 2 degrees of freedom. 2 degrees of freedom. So we're going to look it up right here. 2 degrees of freedom and 8.48. Oh, we just disproved our null. We said it shouldn't show any difference, and lo and behold, it has. So we can come up with the conclusion, this is significant, we disproved the null, and therefore we can say their exercise campaign made a significant difference. We can state that with mathematical facts. That campaign made a significant difference. Hey, ask your bio buddy now, do you get that?
Do you get that?
Do you need me to, do you need the other picture too, or are you good? Good? Okay. And that would be it. There are some questions. Do you want to? Does anybody want the questions? Or are you ready to go home? It doesn't hurt my feelings. Questions? Sure.
Thank you, Miss Lynn.
You're welcome, sweetheart. Do you feel better about your chi-squaredness?
Yes, so much better.
Okay, good. Are these the, oh, these are still good. Okay, thank you, sweetheart. Okay, make a commitment if you're doing it so I can move through these. Anybody else still committing? Okay, I'm going. All right, the ultimate source of all energy is the big yellow one, the sun. Okay? Plants just capture any energy for us. There are other autotrophs too. There are chemotrophs, so you wouldn't pick that one. All lowercase, what is the mechanism for evolution called? All lowercase.
That one word, yeah, it is.
2 words. First one starts with an N.
Oh, that's good.
Okay.
That was great. Okay. No, I know I got it right.
This one isn't multiple choice.
Is there no space?
Uh-huh. Were you here at the beginning?
Yes.
Okay. She says with sarcasm. Okay, not waiting anymore. Good, a bunch of you got it. Natural selection. I bet the ones that missed it just don't know how to spell. Natural selection. Okay, good. This is one of your terms, but I didn't review that today. Might start with a T. I believe it was one of your terms. Was it one of your terms? Yes, it was a term. Yes.
Are the terms gonna be on this?
What would you guess?
No. I mean, like like all the specific ones we have to know.
Yeah, those are, that gives us the vocabulary for all of our discussions, so I would be very familiar with those terms. I won't have you write them out verbatim, because that's what we have Google for, but you want to be able to use them, or if I use them, you want to make sure you understand them. And this is one of them. Okay, so you wanted to say theory, or scientific theory, not taxonomy. Taxonomy is how we classify. Testing is how we do experiments. This is nothing. That is wrong. Do you remember this from last year? See if you can remember. If it wasn't this, it was another kind of data. Don't say it out loud. See if you can remember it. Okay, that's all I'm doing. Yay, yes. Quantitative data is measurable. What's the other kind of data?
Qualitative.
Qualitative. Mm-hmm. What would this be an example? pH 7.4. Quantitative. Looks healthy. Good. Really the end. Yay! Good job, you guys. Super proud of you. Okay, be super smart.